We've been using the person and tweeter hierarchy throughout this material. Let's use it again. Here I have a very simple console app that's going to create some pointers to person objects and tweeter objects, and it's going to make a bunch of method calls on those pointers. There are a lot of different versions of person kicking around depending on what I want to demonstrate. Let me just quickly show you the header file for person. It just has first name, last name, arbitrary number, doesn't really have any operator overloads or anything much going on, and has some get and set functions here: get name, get number, and set first name. And these are just easy functions for me to call and see what happens within the class. Tweeter inherits from person and has this overload of get name. Any two functions with the same name we call overloading, even if they're in entirely different and unrelated classes. So we have operator overloads, and this is certainly an overload. We have get name here in person and in tweeter, and there's been a number of objects and classes showing up over time in demos with get name functions in them. But get name, in addition to being an overload, is also an override. I want the tweeter get name to be somehow different from the person get name. So let's be reminded of what the person's get name does. It just returns the first name, and then a space, and then the last name. And in here we have an attempt at writing a tweeter get name. We'll go with the first name, the last name, and the Twitter handle. But you notice there are red wiggles. If I hover over them, they say, error, person last name, blah, 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 is inaccessible. And the same for person, first name, inaccessible. Let's go back to person. Right, they're private. Private member variables are not accessible by any code outside the class. I have a couple of options for how to make this right. One would be to add individual get first name and get last name public functions to person for no other reason than to let tweeter call them. That's a bad idea. I see people do it a lot, but it's a bad idea. Another would be to change this private to protected. Protected is a language keyword that says it's private unless the code is in a class that inherits from this class, then it can do what it likes and party on the data. I consider protected to be a to-do list. Right now, get name returns first name space last name. But if you have a business requirement to suddenly change that to last name, comma, space, first name, if these variables are protected, you're going to have to go looking for get name elsewhere in classes that inherit from person. And depending on your platform architecture, it may be a challenge to find all the classes that inherit from person and change them to print out first names and last names the new approved way. My preference, leave this private and use this perfectly good get name function that's already been written. That way, if anyone ever changes get name in the base class, we'll get the changed behavior in the derived class. Much smarter. So I'll just go back into tweeter.cpp, take these, and what I want is to call person's get name. Where am I going to get a person object to use the dot syntax on? Some p dot get name. Well, I don't have one. But I can still call it from in here by using its full name. Return person get name. Now I'm in a position where if someone makes a change in the base class, I'll just naturally get that change in the derived class. I don't have to worry about private and protected anymore. I'm not trying to talk to private variables. This is all good. That makes my project compile, but that wasn't really what we came here for, right? We really came here to see what happens if I talk to some objects using different kinds of pointers. So let's go back and look at this main. I'm creating a person on the free store, and by the way, forgetting to delete it. It's a deliberate memory leak here. I'm creating a tweeter also on the free store, which I do remember to delete. And I'm creating a person pointer that's equal to this tweeter pointer. So just two ways of looking at the same piece of memory out on the free store. And then I'm going to call getName on the Kate pointer that I got from newing up a person, on the Kate GregCons pointer, which is a tweeter pointer that I got from newing up a tweeter, and on the P. Kate Gregg cons, which is a person pointer that came from newing up a tweeter. Remember that the person get name just prints their name, the tweeter get name prints their handle as well. So let's run this. And here's what happens. When I use the person pointer, which is pointing to a real person object, not surprisingly, I get person output. When I use the tweeter pointer, which is pointing to a real tweeter object, not surprisingly, I get tweeter output. When I use a person pointer, which is really pointing to a tweeter, I get person output. Some of you might have expected differently, but getName in person.h is not virtual. And because it's not virtual, I will always get person output. If I want to see a tweeter code for getName run, even when I'm using a person pointer, as long as it's really a tweeter object that the person pointer is pointing to, I need to make getName virtual. Now I only need to do this here in the base class. I don't need to do it in Tweeter. You can if you want as a form of documentation, and I don't need to do it throughout all of the inheritance hierarchy. I can just make this single change here and then just run it. And you see now the tweeter code ran even though we were using a person pointer, because it really points to a tweeter object. And when the function's virtual, that's what drives it. Once I have a virtual function in person, I will have a virtual table, and I will take that small performance hit. At that point, a rule kicks in. Now, it's not a compiler rule. I don't have any warnings from the compiler. This is a best practices rule. I want you to kind of go on a thought experiment with me. Imagine that I knew this tweeter up, and I don't call delete using the tweeter pointer, but instead I call delete using the person pointer that points to the same place. The destructor for person and tweeter is currently non-virtual. Here's a destructor. This destructor actually doesn't do anything. We'd be better off taking it away, but bear with me. We have this destructor. It's not virtual. If instead of deleting the tweeter pointer, we call delete on the person pointer, you know what would happen? The person destructor would run. So what? Well, it depends on the class. If tweeter manages something, like it opens a file, and its destructor needs to close the file, and I delete a tweeter object using a person pointer, I still want to run the tweeter destructor. I still want to close the file, or release the lock, or let go of the database connection, or whatever my destructor is going to do. How can I prevent this leak where we call the wrong destructor? How can I be sure that if the object being deleted is really a tweeter object, that the tweeter destructor runs? By having the destructor be virtual. Now, some people go so far as to say that all destructors should be virtual. I don't agree with that. That just makes the overhead of virtual functions come into every class whether they're needed or not. But a really good rule is the minute you have one virtual function, clearly you're expecting to be using pointers in an inheritance hierarchy and for virtuality to matter. There's a really good chance that somebody might call delete on a person pointer that was really pointing to a tweeter object. And despite the fact that as the person author, I have no idea what might get added to tweeter, I feel safest making the destructor virtual at this point. Don't make the destructor virtual before there are any other virtual functions, but the minute there's one virtual function, get in there and make the destructor virtual. It will save you from a really subtle bug that is extraordinarily hard to track down if you don't just happen to recognize this pattern and this best practice.